Hi there and welcome to our lunchtime insights session. Again, these sessions are being live streamed on YouTube as well as through our website. So post-event, you're welcome to log on and have a look at these if you want further information. But to start us off today, we've got Airobotics to tell us all about automated drones and actionable insights. And we've got David Fraser, who's the mining client manager. So welcome, David.
Thanks, Sean. Good day, everyone. I'm David Fraser, as Sean mentioned, and I look after our East Coast operations for Airobotics. And I just thought I'd give you a bit of a rundown today of not only Airobotics, but also automated drones and actionable insights across the industry as a whole. So just to give you a bit of a visualization of the Airobotics solution, just always helps to sort of understand what we're talking about. And in some cases, or a lot of people do refer to us as a drone-in-the-box solution, whereby the box, in this case, the docking station, as you can see there, about 2 by 2 metres, it actually houses our drone on site and becomes a semi-permanent building almost on site and a place for the drone to not only take off from, but also a place to come back and land and also download that information. Inside the docking station, you'll see there in a second, we also have our the payloads, the batteries, and depending on the mission, the robotic arm will come out. It will change out the batteries to be obviously the one with the most power in it. It'll change out the cameras or the sensors to be that one specific to that application, whether it's a LiDAR, video, photogrammetry type sensor, and away the drone will go at the click of a button from our system operators, and it'll be in the air capturing that data. Just with the automated aspect, it is quite different to the manual flights, as you're well aware. And I just like to try and point out a couple of key milestones quickly in the Airobotics timeline. Early to mid 2017 was when we moved into Australia, and as you can see, we gained in March 2017 our visible line of sight operations over in the west, and followed a couple of months after that, we got our first beyond visible line of sight approval, which in some cases, as you might know, is deemed quite hard to obtain. And I'm certainly happy to field some questions around how we did that in this instance, both in Australia and, as you can see, overseas as well. And recently in December of last year, we received CASA first, as well as a world first, approval to be able to fly beyond visible line of sight solution from a remote operating centre. Now that is, as I said, a world first, not only for drones, but for any, I guess, provider in that space. So that's something that we're quite proud of, and really does enable us to move forward, and especially with that beyond visible line of sight, to expand not just in Australia, but all over the world. So how does it work? It's a very collaborative approach. I do like to say that the product is an off-the-shelf product. The solution is not. It's a very collaborative approach. We work very closely with our customers in terms of planning each flight, areas of change, areas of high frequency, areas that they deem of value, and once we come up with these missions, that they are pre-planned missions. It's not an ad hoc type solution. The missions are pre-planned. The drone, as I showed you before, would be able to capture and grab the sensors for that specific mission. It'll then go and capture that data. It'll come back into the docking station, and then that's when the process is sent off to our GIS teams. It's processed, and this is the analysis and the processing of this data is where the actionable insights come in. You can usually draw a line there and say, here's the data, let's dump it, and you can either use it as a raw format or do what you want, whereas we actually jump in and try and understand the context of why is it wanted, and work very collaboratively, as I mentioned, with the customers. Why do you want that? Is that helpful? Is that of value? Because realistically, their success is our success. And on the back of that, those efforts, a report is then sent out to the customer in whichever format they require. And as an example, a single data point is really useless to anybody, but that same data point out of context, we believe, is also not of value. What we try and do is, as I mentioned, we really try and understand the context. And in this case, with our customers, it was the haul road compliance parameters. So we've gone and mapped with our LiDAR payload a 3 to 5 centimetre accurate area of the high flow haul roads, and in this case the customer has given us their parameters around their haul road construction. So might be 15 metres wide, might be 1.5 metre bund heights. Each site has their own varying compliance matrix that they need to meet. Airobotics has now come up with being able to apply that context whilst we have the data, giving it back to the end user, to say, well, here is your compliance matrix, and as you can see, it's quite simple but yet effective to say, well, here's your two-way crossfall. It might be below or above 3% grade. Here's the width of the haul roads. Red, as you can see, is obviously going to be a little bit narrower than that, say, 15, 16 metres, whatever you tell us. Green is on par. We can then jump into hydrology analysis, so we can understand, again, due to having that 3D formatting of the haul roads, predictive haul road maintenance. Where's that water going to pool in the wet season? Different aspects like that. And then finally, the bund height, again, just being able to measure the height. Where are you on? Where are you off compliance? And just as an example, we can tick through there. We multiple different colours. You're either on, off, or within your own compliance matrix from that point of view. Some other applications that we get into is stockpile analytics. Now, stockpile is, I would say, drones' bread and butter. Realistically, do we do it any differently than others? The only main difference that I would say would be the frequency that we can do it. Given that it is based on site permanently, it can just get out there multiple times a day if required. Some people may only want it 3 times a week, once a week, fortnightly. That's up to you. We're simply there as a service provider of your stockpile. It gets away from having to just have your monthly reconciliation. The interest and I guess the value add that we can do on those frequency is purely driven by the end user in that space. Construction management, working again with compliance to plan. We're able to work again very collaboratively. Give us the plan, what you're trying to work to. We can give you a daily, second, third daily update of where you are to a percentage to that plan. You can allocate resources and understand, specifically where you are in that project. It's not a suck of the thumb. Next Tuesday, boss, you'll be right. Next Tuesday comes around, and all of a sudden, you've still got 3 days. So it's just that again, high frequency. Tailings dam management, right from construction through to monitoring. The blast life cycle, we're talking about looking at the bench, we're looking at fragmentation, we're videoing the blast. So there's a multitude of reasons and applications in that one life cycle there, as I'm sure you can all imagine. Haul road analytics, I just went through that one. Again, that's ever changing. Some are highly valuable, some really couldn't be bothered. They want to understand the hydrology. They don't really care about the bund height. That's again driven purely by the end user. And site surveillance. So we've obtained night flight as well. So we're able to fly. So let's just say IR for some security missions. You can obviously pick up heat detection at night for your surveillance. And just on night flying with the LiDAR mapping, we're actually able to get those mapping missions done in the night time and produce the results, first thing that morning. So you can actually come in, get the results, rather than your first object would normally be to go and actually fly that yourself. So that's a bit of a time saver on that front. And I guess in reality and in conclusion on that front with the automation side of things, and we really do believe that the automated drone in this case is simply the platform for the data. I mean, to get that data, you don't really care how we do it. We think it's really cool that it's a drone and it flies and we're breaking barriers, but honestly, that data is what you need. And we're not out there to replace jobs, it's replacing tasks. As I mentioned, if you have to come to work at 6 o'clock, you mightn't get back to the office until 10 with the data that hasn't even been processed yet, whereas we're replacing that task. We're out there, we're capturing that data for you, we're processing it for you, and we're doing our best to provide what we believe to be pretty valuable insights with that data, and as I said, the actionable insights. You can actually do something with that, and freeing up time. That it says it itself, but we're seeing now that especially with surveyors, they work quite standoffish. And not being a surveyor myself, it has been quite interesting to see that they're now becoming almost the site champion. We're really looking to empower those people that actually use the data now. So not only are they were responsible in this case for capturing it, for processing it, and then coming up with the insights, what they believe. They now are at that insight point straight away. And so what they can do is they can grab that, they can actually go and sit on a dozer, sit on an excavator as a geologist, surveyor, engineer, and really start to use what they've probably been hired for, and let us get away with the airspace regulations and that flight control. So that's pretty much where we are there in the end, just around automated drones and how we believe we can really dive into the actionable insights from what we can capture. So I'm out of time, but we're at booth 9. So if anyone's got any more questions around airspace regulations, drones in general, the way the business is going, please come and see me. And it'll be a pleasure to continue talking to you. So thank you very much.
Yeah, thanks very much, David, and thanks to Airobotics. Airobotics was one of our foundation partners for the original Future of Mining event last year, so great to have them back again. Our next speaker is from Xage Security, and they're talking about blockchain security for the modern mine, and this is a very topical issue, especially with cyber security. So on behalf of Xage, we've got Phil Pereira. If you'd like to come up, Phil, and deliver your presentation, welcome. Thank you.
Okay, to start with, to position Xage and where we're coming from, we see a lot of the modernisation drivers is one that we've always seen for a long period of time, is volatile commodity prices, high manpower costs, which we're seeing at the moment, increased automation, which is relatively new to the mining environment, and a need for increased security to maintain safety, which we're seeing from terrorism and so forth at the moment. So that's positioning where Xage is coming from. We're starting to see a lot of consultants in the industry. They're starting to raise this as a real issue in terms of security. Ernst & Young had an interesting report relatively recently. They're basically saying that cyber risk, at the very least, can destroy your organisation's productivity gains and really put back your digital advancement into the future. So at the very least, what it can do is slow things down. Cyber security overall is something that's just been talked about quite a bit, and I'm running through this fairly quickly for you. The main drivers that we see from Xage is that industrial security is nothing like enterprise security, and we've spent a lot of money, we as a civilisation spent a lot of money over the decades securing the central site. The glasshouse is quite secure. The industrial area is not secure at all. We find that industrial security needs to be decentralised, it needs to be adaptive, and it needs to be autonomous. And that's very, very difficult to achieve in enterprise type security. Of course, one thing with mining especially is that you've got intermittent connectivity out to the mine sites, whether it's just down the other end of the mine site itself or actually getting to the mine site in the first place. Also, in industrial security, it has to be real time. It has to be multi-vendor, because you've always got a lot of different vendors out there in the mine sites. And it needs to be peer-to-peer communications. The other thing that is really challenging to try and secure a mining site is you're running all sorts of different industrial protocols. And all the devices have got their own username and password, and most of those, of course, are still on the default passwords, aren't they? Right, and they've been that way for the last couple of decades. So what we're saying is that industrial systems need more than corporate security, much more, and it needs to be looked at a totally different way. So we have a lot of unprotected protocols. There's deployment and enrolment of devices, and they don't have a central served trust, okay? Shared trust, I should say. Now, the thing that we're also seeing out the field quite a bit, we're seeing a lot of malware and botnets attacks, which you probably had a number of those already, I'm assuming. The other thing that we're also seeing, especially in a mining environment, you're getting very limited visibility into edge devices and applications. A lot of the equipment's been sitting out there for many years, and a lot of organisations don't actually know precisely what devices you've got out there, or how many even, okay? And of course, in a mining environment, you've got to have continuous operation 24/7, right? And a lot of organisations got ineffective access control. So you've got people potentially going out on site that are being given password access to some devices, then they leave the organisation, perhaps they're contractors, taking those passwords with them. Now that's exposing your sites quite a bit. So one of the technologies that we use to secure what we're doing is we use blockchain security. Now that's a nice buzzword at the moment, but what it means is it's a distributed ledger system. So we need to have some way of securing information out in remote sites that's secure. And of course, the more devices in blockchain, the more devices you have, the more secure it's going to be. Now, just briefly, what a distributed ledger is, information shared over a number of different databases. It's encrypted, of course, but when you ask that ledger for information, all of the databases have to concur. Okay, so you might have, say, 10 out there. If one says, no, I don't concur, we say, okay, you're corrupted or someone's tried to corrupt you. So how do we protect a mine site, for example? We have a central Xage broker where you allocate resources to a particular employer based on their role or job function at the time. We have a number of gateways that are using the blockchain security, blockchain distributed ledger out on site. And what that means is if you lose communications from the central broker, the Xage fabric, as we call it, which is established by the gateways, is able to maintain the security for you and secure access. Then once the communications comes back on board, that distributed database can be updated. But at least while you have no communications back with the central site, everything's ticking along quite fine. So what's the benefits of that? Well, we can establish identity and authentication and remote sites. And when I'm talking remote sites, that could be just down the other end of the mine site. Not that some of them are very small. We can eliminate unmanaged passwords. So instead of giving someone a username and password for a particular device, they log on to the Xage system. Xage looks after the log on to the individual device and then allocate the resources accordingly. So, for example, an employee never gets to see the password on a particular device. That's managed by Xage. So once that person leaves that role or leaves the organisation, he doesn't get access to those devices that he had access to before. So that maintains your unmanaged passwords. Again, you're managing your access control on a person-by-person basis or a device basis. The other thing that's neat with the distributed ledger system with blockchain is you're recording all operational transactions. So if someone is using a piece of equipment, that's recorded in the database. So you can go back at a later stage if there's been an issue and you can establish who has used that device and at what time. That helps you prevent malware attacks because they cannot get access to those pieces of equipment. They're locked out of it because that's being managed by Xage. They've got to try and break into the Xage system, and that's a very difficult thing to do. What we're doing also is key management. So the Xage system is actually looking after the passwords out on those remote devices. Once they're logged into the system, because another thing a lot of organisations are finding it very difficult to do is get out onto those individual devices and change those passwords on a regular basis like you're supposed to do. Xage does that for you. Security at scale, that's what Xage does. So the larger the system, the better it works, even when there's intermittent communications. It's fully redundant and self-healing, so as soon as those communications come back on board, it updates itself and keeps running. The interesting thing is that we're looking at cooperation between humans and devices. From device to device, we manage the interactions between those devices and even between applications. That's all managed. That's what Xage does. That's the fabric that I was talking to you about. And again, because we're using blockchain, the more gateways, the more devices involved in the whole fabric, the more secure it's going to be. Which is the opposite to what you'd think it would be. So for the first time, what we can do is give you a holistic security across into every single individual device in the network, modern or legacy. We're vendor agnostic, we work with everyone. As I said, it grows stronger every time you add another device or another gateway to the system. You get system-wide visibility of every device on the network. There's something that you probably don't have at the moment. So you'd have a lot of legacy devices out there. They need to be brought into the fold and controlled, and so you can see how they're operating and who's got access to them. They're easy to deploy and it's self-sustaining. You remove operational complexity. That's what it's all about. What you want to do is make it easy for people to go out there and have access to devices as they need, but you want to make it secure. Enable secure and remote access. We'll manage that as well. Advanced automation is going to become more and more critical, that you try and secure those devices if you've got automated equipment out there. So we've got a vendor agnostic solution for everything. You'll be able to rethink your work processes. Instead of giving people access to individual components and letting them onto the site and potentially them keeping those passwords, you'll be able to rethink things and reorganise things a little bit differently. You'll be able to set up roles on a time basis or an individual basis. You can extend the useful life of deployed assets. Now what I mean by that, it means that you'll be able to keep the older ones that are out there, the legacy devices. They don't have to be replaced, they can be managed under the same system. So there's no need to replace them or recommission those devices. That's it. Okay, that's very quickly what Xage does. I wasn't watching the clock, so I'm assuming I'm over time. Any questions? We're over on 11, isn't it? Number 11. Okay, come and ask us questions. Thank you.
Thanks very much, Phil. As you mentioned, they have an exhibition space here. It's directly opposite the main ballroom, I think. So any questions, see Phil and the team at Xage. Our next speaker is from Minnovare. We have the Managing Director, Callum McCracken. And Callum is here to talk to us about increased production drilling accuracy leads to reduced dilution at Evolution Cracow. So welcome. Thank you.
Thank you very much. As outlined, what I'm going to talk through briefly is a collaboration that Minnovare had with Evolution Mining a couple of years ago that resulted in the development of a new piece of technology. But importantly, I'll also touch on the value that that collaboration has delivered, not just for Minnovare, but importantly for Evolution, our development partner. Briefly about Minnovare, we specialise in advanced drilling technology. We're headquartered in Perth. We also have operations in the US and Canada. We developed and launched the Azimuth Aligner. It's now the most widely used drill rig alignment system within exploration. And on the back of that, in early 2018, we launched the Production Optimizer, the technology that I'm talking about today. Our technology is used in over 120 mines globally. And as a business, we place a strong emphasis on collaboration. One of those is what I'm talking about today. Evolution are a company that really don't need any background. Cracow itself is an underground gold operation in Queensland. It's got a narrow vein, steeply dipping ore body and use a long hole stoping extraction method. They output around 90,000 ounces of gold per year. Why they were such a great partner for us was quite a bit of work had already been done by the engineering team to determine the issues they were facing and also identify some of the causes. And what they found was that blast hole deviation in their long hole drilling was causing excessive dilution and rework due to bridging. This was actually being exacerbated as they mined deeper in the deposit due to the narrowing of the ore body. And they also noted that some of the complexity with the process and the technology used to align the rigs was a contributor to their issue. So why was this collaboration important? Well, for Minnovare, it gave us access to a real-world test facility, a working underground mine, but also it enabled us to identify and engage the key stakeholders. This meant that we could identify who they were, what their needs were, and ultimately we knew that would streamline the adoption of our technology once the commercialization had been complete. It also enabled us to build a more valuable solution based on the needs of the customer. And again, we saw that this was a benefit not just for us, but for our clients and for the industry as a whole. Cracow was also an ideal test case because they had done an extensive drill hole deviation study in 2016. And what we found when we sat down with the engineering team to look at that data, it actually aligned really well with analysis that we'd conducted from 5 other underground operations in Australia. And that was data based on in-hole survey data that our clients had given us to conduct some analysis. What this slide shows is this is really a summary of that analysis that we conducted. So on the left-hand side, you can see is the percentage contribution that alignment error, collar position error, and in-hole deviation was having to the overall deviation at the end of a blast hole. So what this data was, it was a combination of in-hole survey data and collar pickups from mine surveyors. And what we can see is that actually the alignment of the drill prior to drilling of the hole was actually the largest contributor to the deviation at the end of the hole. Second to that was in-hole deviation, and finally collar error or collar location error. But importantly for us, and the key takeaway in the problem that we wanted to solve, was that over 75% of the deviation at the end of an underground blast hole could actually be attributed to factors that occurred before the drilling actually commenced. Another challenge that the engineers at Cracow had identified was some of the complexity associated with the alignment of their long hole rigs. They had noted that there was multiple sensors on the rigs, all needed to be maintained and calibrated to get an accurate outcome. A key part of the process was the surveyor marking a laser reference line and an operator orientating the rig to that reference. And really the outcome here was very much dependent on the skill and the diligence of the operator. We saw that the systems could break down from time to time, but importantly, there was often a lot of data, but it wasn't being collected, it wasn't being analysed, and it certainly wasn't finding its way back to the engineers in a timely fashion. So what we found was that the alignment accuracy was really dependent on the surveyor, the rig, and also the drill rig operator themselves. So the technology that we developed was really developed to overcome some of these challenges, and it became the production optimizer. Importantly, when we started, we had a focus to ensure that this system could be retrofit to any make of model, regardless of age. And what we've seen from our clients who have implemented this technology over the last 12 months is a reduction in their average blast hole deviation of up to 70%. I'll touch briefly on some of the key components before moving on to the results at Cracow. But our digital platform, Minnovare Core, is our online data hub. Importantly, that integrates with the drill and blast software already used by our engineering clients. But importantly, it digitizes what is still very much a paper-based process on a lot of underground mine sites. The second part is those digital drill plans are then passed to the engineer, and other critical information that occurs during the drilling process captured, and then that information passed back to the engineer at the end of shift. Our OptiBox is a highly accurate sensor that we retrofit to the rig. It works independent of the rig's current systems, and it ensures that rig leveling and alignment to a laser line are now a non-critical part of the process. And finally, the smart collar feature gives the driller an automated means of calculating a new trajectory for their hole to ensure they end up in the same place in the event that they have to offset their collar starting location. So onto the analysis. Once we had finished the testing of the system, Cracow moved ahead with implementing it on their 2 underground long hole rigs in January 2018. And at the end of the financial year, we sat down with the engineering team to conduct an analysis to actually quantify the benefits the system had delivered. The engineers selected 28 stopes, which represented about 20% of the total production for the financial year. And what they were able to see was that the production optimizer had reduced their average deviation by 30% across those stopes. What they also found was that the 17 stopes that had been drilled using the production optimizer recorded a 63% reduction in dilution when compared to the stopes that they had analysed that had been drilled using the conventional means. This is this data displayed in a different way, and there's really two key takeaways from me here. First of all is the reduction in average dilution. You can see goes from just under 30% using the traditional methods down to an average dilution of just under 12. But importantly, if you look at the two sets of data, you can see that not only did the production optimizer deliver a better outcome, but also a more consistent outcome. And that can be seen clearly when we look at the standard deviation. It's just under 19% using the traditional methods, reduced to just under 6% using our technology. Importantly, what does all that mean? So the next step, the engineering team sat down and said, well, if we had achieved these results over a full financial year, what should we have expected from a productivity perspective? And first of all, the reduction in dilution experienced during the 6-month period would achieve overall a 45% reduction over their full year. What that would mean for the operation, in the event that they can maintain the same tonnage output from the mine, would be an additional 8.2 million in revenue from additional ore recovery and 4.5 million reduction in costs associated with dilution. That would translate into a 22% return per tonne increase. And based on that, the mine had the confidence to reduce their target dilution from 20%, which was the target in FY17, down to 10%, which is the target for the current financial year. So in closing, in addition to some of the direct benefits that the mine site achieved, there's actually some more bigger picture implications for our clients. The system delivers a more consistent, more accurate drill hole, and that's enabled engineers, it's given them more confidence to try new stope designs. Our clients are now trying new ambitious blast patterns in an effort to economically blast and extract previously uneconomical stopes. What this means in the future is a potential to look at reducing mine production and development costs through increasing level spacing. And also we see that this technology and the data we capture is key to facilitate a pathway towards the automation of this process. But ultimately, it comes down to the bottom line for most of our clients. And what we've proven we can deliver is an improvement in the net present value of their assets. So that's me pretty much out of time. We do have a booth here. Please come and see us at Stand 8. We also have a detailed white paper that was co-authored with Evolution Mining that provides a lot more detail. And myself and my colleagues would be happy to answer any questions that you may have. Thank you very much.
Thanks, Callum. Ladies and gentlemen, I'd like to welcome Dirk Eisner from MST Global. Dirk is the enterprise architect. Thanks, Dirk.
So we got a little bit of a technical demonstration, so I hope it all goes good. So just very quickly about Mindset Technology. Mindset Technology delivers high-speed wireless backbones and Wi-Fi for underground mines to do any kind of automation and any kind of connection of cameras or third-party devices you have. Over the last few years, we have embarked on developing new devices, and you all probably wonder about what the title is. Albert Einstein doesn't work underground. Well, I worked for a long time underground, and I'm not Albert Einstein, but he said a very interesting thing, that if I can click this forwards, that's what he said, any intelligent fool can make things bigger and more complex. It takes a touch of genius and a lot of courage to move in the opposite direction. And that's exactly what we embarked to do, to make things simpler. What we found is extremely difficult to maintain networks underground and to connect the devices you want. So this is what I used to deal with. Someone comes to me and he says, well, you know, we got this sump pump here, and we really want to know what the water level is and that sump pump. Can you monitor this? Sure I can. In a shop floor, it would be really easy. But in this case, what would actually happen is, first thing you need is power to run this thing. Well, where are you looking? And power is 400 metre down that roadway. It's nowhere near. Yeah, you got 1,000 volt for your pump, but not 240. Next thing you look at is like, well, got the power here. Now I need some sort of power supply. So you buy a box, stick a power supply in, and you go, well, really, when the power's down, I also want to know, how high that water is, particularly then I want to know it. So I need a UPS. So you buy a UPS, you stick that in a box. Then you finally go to the Allen Bradleys or the Siemens or whatever, you buy a PLC, a sensor to measure, an ultrasonic sensor to measure the water depths and the current clamp to work out what the pump draws at the moment. All good. Then you go, well, got to get the data to the surface. No data connection. It's back there where the 240 volt were. So here I run another 400 metre of optic fibre in there. Then I work out the PLC, hang on, I only got copper Ethernet, so I need to convert this. So you see where the story goes. Most of the time, halfway down the track, you're giving up. And someone will say, you know what, send a bloke there twice a shift, having a look at what the water height is in that oil. That's normally what it ends up. So we realise this, and you don't have that just on pumps, right? You have that on the typical secondary fans, all sorts of things. We got people running back and forward, switching on fans, all this kind of stuff. This is crazy. Digital time, really? I mean, you can walk past a shop door out there and the shop door opens up automatically. When we come to a vent door, we pull on some sort of string. You've got to be kidding, aren't you? That's the reality of automation. Yes, we have these centres of automation, where you have full automation, but as soon as you go away from that, it all looks very different. So Mindsight has embarked to build a new network switch, and this network switch is gigabit high-speed network switch, which you can easily deploy. It is ruggedized, quick release on this thing. It's just very, very simple. And what we did is we put an automation module in it. This is not a wild blown PLC where you got to write 50 lines of letter code to do the basic thing. What this is, you can buy off us, you come to us and you say, I want to start my fan remotely. And we go, here's a fan starter kit. Bang, stick it in, plug it in, 3 cables. You go into a very basic menu, electrician level, not automation specialist level. You go, you click, you pick your sensor. The stuff gets automatically transferred to our ICA on the surface. You can pick the people you want to notify or which you want to make able to switch this fan on and off or measure the pump or whatever it is you came from a 6-week 3 guys problem of trying to build this thing to a system which you literally can implement in a half an hour. So this is what it is, basically. It is a high-speed fibre-connected switch which also gives you copper gigabit connectivity, as well as you can attach a modular Wi-Fi unit on it. It's a Wi-Fi unit, high-speed Wi-Fi unit, so if you want to tram your vehicles remotely or whatever you may want to do it, you can do it. So now we come to the tricky part of the animation. So I just want to show you, this switch actually is modular. So as you've seen before on the slide before, it had a Wi-Fi unit attached, but the Wi-Fi unit is completely separate off it. So you can do that. It doesn't work. So you can stick the Wi-Fi unit on, and the bottom modules, you can, it normally plays pretty smooth. You can remove these bottom modules, and you now put your control module in. And that control module has 2 20 milliamp loops, standard automation technology. It's got 2 2-amp relays in. It's got 2 digital and 2 analog ports out, and they're all easy to configure. So the other module you can put in, if you haven't got enough Ethernet, the switch comes with 3 Ethernet ports, which are gigabit Ethernet ports, and they're PoE+. You can add an additional PoE module in there, which gives you 3 more PoE ports. So you can have a total of up to 7 PoE ports on this. Now, one thing we also realized is that, well, you go there, you configure all this switch, and then the guy, whoever configured it, moved away. Now, this switch breaks, someone runs it off the wall. What do you do next? How long will it take you at 3 o'clock in the morning to recover that switch? So what we've done is we put in a very smart little key. Hopefully it comes up. You want to go to next? So in there is a little data key, And that data key holds the entire configuration of that switch, including all your automation modules, all your stuff you have on there in there. So you take that switch, and it's a quick release of that switch. You take it off the wall, you take your new one, and it can be the electrician. He puts it on, he plugs the cable back in, he sticks that key back in, and surprise, surprise, it is exactly the same switch. There is no software configuration needed. No one needs to do anything. And this is basically what we set out to do. We set out to make networks, underground and automation useful in a means that most of the time the things we've seen, you know, people are very enthusiastic in deploying these things, but then after a while you come there, it's broken down, no one can fix it. The guy who built this thing has left the mine, and all is over. So that's basically what we about. So we're going to add, I think, a very essential part to it. And there's sort of all these things like, you know, you pull on a cord, a vent door opens. You want to know the current. The electrician wants to know a current on a particular cable. You put it on, and you can read the current. And it's simple. It's very, very simple for use. Thank you.
Thanks very much, Dirk. I'd like to welcome Rohan McAdam from Honeywell, who's going to talk to us about industry best performance by transforming process, people, and asset data into actionable insights.
Thank you. So I'm Rohan McAdam. I'm Chief Architect and Senior Engineering Fellow with Honeywell Process Solutions. And I'd like to show you some of the work we're doing to take data related to process, people and assets and turn that into actionable insights and recommendations. In terms of background, there's a number of key challenges that everybody's facing. One of those is increased complexity of the operational and business environment. So that there are continual product and quality requirement changes. We have, you know, a range of assets that are aging, and we need to maintain the performance of those assets, or ideally improve the performance of those assets over time. There are increased requirements for environmental and safety compliance and stewardship. There are workforce issues with turnover, skill gaps that need to be quickly and effectively closed. And there's an issue relating to data as well. So in some cases, the problem is that there's simply not enough data to make informed decisions about the current operational status of a facility or an organisation. In other cases, it's the reverse. There's too much data. And that's the second point here around point solutions that drive efficiency, reliability and safety. So today there are a number of point solutions that operate in those areas. They're increasingly model-based digital twins that can provide important and interesting insights into the performance of key dimensions of operations, but they tend to be disconnected, disparate systems with limited analytics across those solutions, which means that important insights and relationships between those aspects of operations get missed. So actually, and what makes that worse also is the user experience provided by a lot of those tools is actually quite poor, which makes it all the harder to synthesize information from these disparate sources, understand what they imply, and plan a path forward. So there's really a need to move from just the problem of integrating data to create, if you like, intelligence integration. So take what's available in these point solutions, bring that together in a way that makes it much easier to understand and act upon. So, and as we do that, what we want to do is we want to be able to understand what's the operational situation, how does that compare with where it could be or should be, move to a more exception-based way of working based on alerts and notifications that drive people to focus on the right things at the right time in order to maintain and improve operations, and close the loop on the understanding of what the situation is, what it needs to be, how to achieve that, and then understanding the results of that as we go on. So what might that look like? So the key thing here is to build a layer of intelligence over the top of the point solutions that we have in place, as I said, which are typically increasingly model-based digital twins, to provide an at-a-glance overview of the operational status at various levels. So here we have an example from a fictitious mining company. In this case, it's an enterprise level view, which is showing us some key KPIs related to key dimensions of the operational situation, together with something which is very useful, which is a roll-up of opportunities for either improving or protecting the operational situation, which is being surfaced by the underlying digital twins. If we look at this, we can see that, in fact, one of the regions in this mining enterprise has, of the $7.8 million of opportunity that's been identified by the underlying analytics, of that, $2.21 million applies to one region. If we drill down into that region, we can see a similar situation, but now focused on a region where we have that opportunity now broken out across various mines in that region. And we can see one particular mine has the biggest opportunity associated with it, which is the Yandi mine at the top there. And it accounts for $603,000 of that opportunity that's been identified by the underlying digital twins. We can also see that there are some specific recommendations related to the operational situation starting to appear, again being surfaced by the underlying digital twins. The important thing here is we're bringing that information together into the one holistic, coherent view of what's happening to make it much easier to understand and act upon. If we drill into the Yandi mine, we get an at-a-glance view of what's happening at that particular mine. And again, this visualization draws your attention immediately to the fact that there's some sort of issue with overall asset effectiveness. So that's worth looking at. And if we have a look at that opportunity in the top right-hand corner, we can see that of that $603,000 of opportunity at play, $125,000 of that has already been realised through various activities. There's $145,000 in progress, and there's still $286,000 on the table. So just given that high-level view, it's probably worth drilling into the asset aspects of this particular mine. We can go to what we refer to as an operational guidance display, which is now giving us a much more detailed overview of the operational situation for that particular mine. On the left-hand side, we can see we have some key production-related variables. In the centre, we've got the performance of key assets at that mine. And then on the right-hand side, we've got these recommendations which are pertain to the assets and the production variables at this particular mine. So if we have a look at the mobile haul fleet, we can start to see that there are relationships surfacing now between the assets view of things and the production view of things. So we can see the mobile haul fleet is impacting on a couple of key production parameters there, the run-of-mine feed rate, plant feed rate. And also on the right-hand side, we can now see there are specific recommendations related to issues for that particular asset. If you go ahead and drill in a bit further and have a look at the particular recommendation there, it's related to a particular haul truck. It's recommending that there's a maintenance activity take place because there's a potential plugged oil filter which could lead to the failure of that asset, which would then cost us $205,000 a day. So at this point, we could go ahead and raise a work order to get that fixed. What's important here is we've been led down this path without having to be a specialist in asset performance or production performance or anything like that. We've taken that information from those underlying digital twins and presented it in a way that makes it easy to navigate. At this point, we could go ahead and start to close the loop on this by raising a work order, or it may be appropriate to drill into the particular digital twin which surfaced this recommendation by engaging a subject matter expert, an asset specialist, to maybe have a look at a detailed view provided by that digital twin of the haul truck in question. Okay, this would allow that specialist to verify, yes, there's a problem with the engine, there's increased oil pressure, which is consistent with that postulated plugged oil filter, and we should go ahead and do something about that. So we can go back. At this point, we could raise a work order, get that issue fixed, which would then resolve that issue, return that truck to service, and we should then start to see that the impact of that in the overall operational view of the organisation, of this mine in this particular point here. So, and so if we look up the top right-hand corner, we can see that we've got now, of that $603,000 opportunity that's been realised, we've now claimed $345,000 of that. There's $145 still in progress, and there's still $66,000 a day which is on the table. At this point, we might want to direct our attention to the dozer fleet because there's potential impact there. So what we're trying to do here is, pull that information together that's available in disparate sources today in a way that's easier to understand and easier to act on by providing a layer of intelligence over the top of those analytic solutions, those digital twins. The goal for us is to help make every day of your production your best day of production. We want to allow operations teams to quickly and easily determine what the productivity and the asset reliability and people effectiveness is at a glance. So these are tools for operations teams to help them do their job more efficiently, more quickly. As part of that, being able to identify quantified opportunities and actionable recommendations associated with those without necessarily having an expert in all of those various dimensions of the operational situation, perhaps engaging with subject matter experts as needed, but then going on to prioritise, assign and track that work to close the loop on the recommendations that have been surfaced so that you can bring your operations closer to where they should be, whether that's optimal or particular targets or plans. So if anyone's got any questions or further interest, we can talk about that after this session, but that's all I had. Thank you.
Thanks, Rohan. Thanks, Rohan and Honeywell. Guys, that's the last session of this block, but the work streams will be starting over at the main stage area in about 5 minutes. Thanks very much.